I mean, we are right next to the our district is they will only 1 mile.
Okay, folks, we're going to get started. Yep. So while the Venn diagrams for SDS and DAngelo technologies contain some crossover, while the Venn diagrams for SDS and DAngelo technologies contain some crossover, it was important for us to have our next speaker here today simply because of the level of confidence that people have in their work. Whether it's engineering, prototyping, R&D, or training, DAngelo Technologies sets the bar for technological advancement. It's with pleasure that I can introduce to you, if you don't know her already, Dr. Maurissa D'Angelo, CEO of DAngelo Technologies.
So I too have to remember to stand here. And much like Dan, I did not give too much of an introduction on myself, so I apologize. But today I'm going to talk about integrated training with advanced technology on and off the battlefield. And I wanted to start off because I know that several people here know who I am, with a little bit of background on why I'm talking about advanced training. A lot of you know me from the aerial delivery world, a lot of our electronics and wiring systems engineering services, where there is some SDS crossover. But my background is augmented virtual reality, integrating, I call it data mining. We all like to call it, AI, ML in today's world. But I truly believe that affects everything we do. So looking at understanding the true need of the warfighter and what we need to get in their hands through advanced training, but it also drives a lot of our product development. And to Brian Kennedy's point earlier, when he was talking about bringing funds into the Pittsburgh area, we are in final contract negotiations for a training-based system that will be here in Pittsburgh. So we're pretty excited. So I'm going to talk about kind of this right-hand side. So looking at not just advanced training, but looking at how do you do the knowledge capture and dissemination training properly. So an overview, I like to mix everything into extended reality. I'm a big fan of this new kind of catch-all of AR, VR, MR mixed into extended reality. And why I think that's important is I think it's very difficult to say a lot of our training is true VR, true AR, true mixed reality. So everything I do, I lump into that extended reality version. I'll pick out some VR. I mix AR and MR together, but kind of that umbrella. And then I'll talk about some training environmental challenges where we're using artificial intelligence and machine learning to fix the challenges and to improve trust. So big autonomy is big now, autonomous systems. How can we use some of that training to improve trust of autonomous systems and really look at that human machine interface? So depending on what industry and who you talk to, people say, oh, AI is going to, replace us in 10 years, or AI is going to do this. I talk with a lot of folks. There was a big AI conference every year here in Pittsburgh. If you talk to the banking industry, they're like, this is the greatest thing ever. We can use AI and determine if there's fraud or if there's, somebody trying to do something wrong. But then they always go back to the human in the loop. Somebody else is always verifying that. And I really do think, we'll have this conversation 10, 15 years. There'll still be a little bit of that human in the loop. AI will support us. It'll improve our capabilities, but we'll always need that human decision-making capability. So training environmental challenges. One thing I want to highlight is the changing landscape. So it used to be kind of this brute force warfare. Modern warfare still has the brute force physical activities, but you need that cognitive enhancement. A lot of folks, when I get out there and talk to them, especially kind of higher level military folks, say, we don't need this. We can do the training the way we've always done it. Which is a great concept, but without using advanced technologies, we're falling behind the adversaries. So I think looking at it as, yes, we still need to do things the way we've always done it, but we need to augment our capabilities with additional capabilities. And I'm cheating here with notes as well. My initial presentation as of like, say, Sunday was more looking at advanced technologies. I had all these great advanced technologies to talk about. And then last week I was at Soft Week. And I went from kind of company to company, and I'm talking about their great AR, VR, AI. And I kind of realized, look a little backward. So when VR kind of first came out and AR developed, a lot of these companies threw this technology out there and said, hey, go use this. And there was nobody stopped and said, what is the need? What is the training need? How can we use this AR and VR properly? How can we integrate machine learning capabilities? And as I walked around with Soft Week, when I went to the vendors developing them, they said, look at this great new technology, it's awesome. And then when I talked to the soft warrior, they said, well, I don't like this because it needs to have this, or I don't like this because I'm not adding anything to my person. I already have enough weight. So I think one of the things I challenge the training community to do is step back and look at what is this knowledge that's needed? What is this training that's needed? And how can we integrate it with the needs? Oh, we'll go to the next slide. All right. So virtual reality, I would think by now most everyone's heard of virtual reality, seen virtual reality. Kids or some of us here have it, in our house, we're working with it. A lot of people have heard of the Oculus or the Vive, different systems. But really the goal is this immersive simulation where you can create realistic scenarios. Ultimately, I feel it reduces the training costs. I think sometimes up front when you work with the warfighters, they see a big upfront cost to customize it. And that's one thing that later on in my slides I'll talk about is a challenge to standardize. We have hundreds of different virtual reality developing companies. How can we standardize against the platform so that more folks can contribute, so that you can have this system across the board that you can easily update and optimize? What I found for virtual reality really is training high-risk tasks in safe environments, giving that realism. The one example I like to use is like when you think about, from an engineering perspective, think about learning physics in high school or college and just getting that concept of a spring concept, putting it in a virtual environment where you can really see it come to life. We see a lot of that in military environments where you can start to understand the dangers of decision-making within a virtual environment. So this is a little bit of an eye chart, played around with PowerPoint, letting me choose different colors and probably should have. But what I wanted to highlight here is the VR technology capabilities that we've probably had for quite some time, but now we're starting to integrate into different components. So that 6 degree of freedom movement tracking, there's a lot you can do with that now. So you can track a person's movement. You can look at how they're moving, where they're moving, look at eye tracking, where they're looking, different components like that. What we found with the movement tracking is even though the VR has that human in the loop, you also now have the ability to look at somebody as like an avatar or as a individual in the training and not the person themselves. So we've had a lot of buy-ins with, oh, Brett's wearing a blue shirt today and I hate blue, or Jan's wearing a green shirt and I hate green. Now we're putting them as an avatar. There's no longer that bias of the person. You're looking specifically at the training. So we found a lot of help there. Haptic feedback. I feel like I can't do this description justice, but if you have the opportunity to work with anything related to like high fidelity haptic feedback, you can feel the level, like force feedback, like from a medical perspective based on tissue type. Like you can actually feel different tissue types and different feedback within haptics. So I think that's a huge component that's sometimes often overlooked. Spatial audio, so a lot of advancements in spatial audio have allowed us to have that threat awareness, understanding where things are coming from. The realism of the environment, so like LiDAR scanning, photogrammetry, satellite images, knowing where you're going before you go, having that tactical advantage of what you need to do. The high definition capabilities, so the HMD that I worked with like 10, 15 years ago cost more to repair than the HMDs today. So I think just having that understanding and expertise. We're starting to see a lot of real-time observation, but also real-time intervention. So changing how someone's doing training as they're going. Physiological response, and this will be the same for AR and VR, not just being able to monitor it, but also being able to induce change. So a lot of these military environments are high stress, mass casualty. It's not a take the time, want to do this. It's know what you're doing right away. So inducing that stress in the training environment is pretty important. And then tracking, looking at motion platforms, and then really that human in the loop integration. So just some use cases that I wanted to highlight. The parachute training. So that's been around for quite some time. I think what's important there is how far it's come. So now you get in a parachute simulator. We call it virtual reality, but it's also, a lot of the physical. I call it, that's where I like the extended reality, because you're in an actual trainer, even though you're putting a headset on. But the realism of understanding without making a mistake while jumping, to be able to make those changes as you're training. Again, combat training, we talked about medical training, synthetic environments. There's a lot being done in a lot of European nations. So Norway has a standardized training for military across all of Norway. The UK does a lot with procedural training and virtual reality. We're moving a lot to combined training. So think, I can go and do something wrong and have a chemical event exposure, but I'm safe because I'm in a virtual environment. A lot with nuclear training. And then BATDOK, there is some integration with virtual valor training, so medical simulation training into BATDOK. A lot with Navy medical modeling and training that we've learned a lot in these environments. And I think that VR is also not just changing training, but changing our approach to training. So if I tell you, you need to take these 6 steps to get home, but you can take 6 different steps and get home. In this VR environment, we're starting to learn there's more than one way to get to a location, or there's more than one way to do an activity. So how do you expand that? What I will say, what made me a believer in VR is about, it's been a while. So 15, 20 years ago, we had a high fidelity, really expensive headset. We had an individual who was sitting in a chair, and he's a helicopter pilot. And we were going through and we're doing his training, and he's gone through his steps. He's up in the air, he's flying the system, and our system broke. So it's just a black screen. And so he said to him, all right, get out of the chair. We have to fix this. We have to go through it. He said, no, I can't. I'm in the air. Like, he was just so immersed in this environment. And this is a long time ago, right? So immersed in this environment, he couldn't even get out of his chair, even though it was a chair and not a helicopter seat. So I think there's a lot of validity to being immersed in those environments. So augmented and mixed reality, where I differentiate this, obviously, you're not in an enclosed environment any longer. Now you're looking at overlay of information on physical environment. Now, I will say it doesn't have to be the actual physical environment. You could have a mock-up of the environment, or you could have a mixed reality where you're simulating different components and overlay in the real world. What I see this used a lot for is not just training, but also operational environments. So where there's real-time overlays and updates. I think this is huge for the next generation of warfighting, because it's giving you that cognitive advantage. So it's giving you that additional information and that additional capability. We see it a lot in field exercises, right? You're getting real-time feedback. So especially in a lot of the different training and field exercises, we see augmented capability. A lot of times there's a human in the loop. Sometimes there's that AI ML guiding these individuals. And then see-through display system. Kind of jumping ahead a little bit, but one thing we see with augmented reality and somewhat the virtual reality is comfort level. But how do we make sure that those systems are comfortable and our warfighters want to wear them or use them and they're helpful? So this touches on a few things that I had talked about. We are integrating some of our AR systems with tactical equipment. Some of it has gone horribly wrong. Some of it has gone well. I think it's still quite a learning curve. Looking at audio components into the scene. One thing that we find pretty beneficial is that remote expert instruction. So they see what you see. They're looking at what you see. I always use I'm going to butcher the name, but the ThyssenKrupp elevator. They have a really good example of a remote connection They're looking through glasses. This is an older one, so it's like the dyno lens, but they're looking through the glasses and they're saying, hey, I can't figure out how to fix this elevator. And you have this expert who maybe is retired or can't be out there, and he walks this person through exactly how to do things. So I think there's a lot of capability to have that remote instruction as well. Overlaying of performance metrics is also another important one. So real time, you can tell an individual how they're doing or what they need to make changes. It's a standalone system, so for VR and AR both, a lot of our systems used to be tethered. Having that standalone free walking capability is pretty important. So AR, MR use cases. I'm going to highlight this picture on the right real quick. So this is an AR use case using actually an iPad. So walking through. One of the things we're finding with AR, depending on who you are, what division of the military you're in, where you're doing what you're doing, is handheld versus a wearable. We're seeing more growth in augmented reality now with a lot of handhelds. Where when I first went into this, I thought everyone's going to want a wearable. You want your hands free, especially if you're doing maintenance. It seems to vary depending on, like, Navy seems very interested in handhelds, where Marines and Air Force want the headset. So I think that's another area that's pretty important as we develop AR, VR type training, is to make sure it's device agnostic. If someone wants a headset, let them wear a headset. If they want a handheld, let them have that handheld. These are just some highlighted AR, MR use cases. So a lot of the tactical advisors looking at that. Maintenance training, AR is becoming very big in maintenance training, not just for the experienced maintainer, but pulling someone, say, kind of off the street in that level and saying, hey, can you change this brake pad? Can you fix this item? And then when I talk a little bit later, having that AI interface that says the person who fixed this for the last 10 years did it this way. If you don't do it this way, you're probably going to have problems and you're not going to fix it. Technical words will take you so far, but having that kind of enhanced capability really helps. Land navigation, a lot of training with the realism and overlay capabilities. Fire containment. There's actually an interesting, I think it was done low level, like at a high school or college, but it was like a flood-based warning. So it was to show you a lot of times when the hurricanes are coming, right? No one wants to leave their house. They want to stay. It's not going to happen to them. There was a pretty neat AR training. So you're in your house and you're wearing an AR see-through device, and it shows you just how fast, if there's a flood coming, how fast the flood comes into your house and fills up. And it actually helped with disaster response when there's a disaster coming, and say, hey, this is going to break, or this tornado is coming. It shows you how quickly a disaster can happen and really drives home to individuals, hey, they need to get moving. So artificial intelligence and machine learning, part of the reason I included this is because I think it's significantly growing in training, and it gives us that competitive edge. So when I look at artificial intelligence and machine learning, I really look at data mining. What's there? What does the human do? How can we take that and train somebody else? Where I feel like it benefits in training, keep forgetting about Mike, where I feel like it benefits in training is really adaptive training scenarios and human performance. How can I take the most intelligent subject matter experts, and how can I take the most intelligent processes and kind of suck them into that training and continuously improve that training. And then look at, data-driven performance analysis and personalized improvement. So, some people are visual learners, some people are auditory learners. How can I customize that within a training environment? So natural language processing and large language models. I think that we've come quite a long way with our natural language processing capabilities. So how I interact with this computer system, scenario interaction, feedback, understanding, looking at that computer vision, right? So when I look at it for rehab specifically, posture and movement, and how can we correct that posture and movement? Looking at predictive analytics, is this person doing the training I want them to do? Can I improve real time? Decision-making quality, so automated assessments. Really, I think AI has helped with VR and AR, both from team environments. So looking at team behavior and how we're interacting, looking at anomaly detection. So not just in the training or military perspective to see if something's wrong, but looking at from the trainee are they not understanding this? Maybe this is not an area where they're going to understand this. How do we fix that? Reinforcement learning is big. So we're working on a lot of reinforcement learning with the Navy right now. We're assessing a ship handling trainer, right? How do they drive the ship? How can we improve how they drive the ship? How can we challenge them? So maybe they're great. You know, they can take the ship, they can go anywhere they want, doesn't bother them. Can we add weather environments? Can we add other ships? So different components like that, where you add to the environment real time, using kind of an artificial intelligence data mining. Hey, this person did this 10 times correct. Let's challenge them, see if they can do it correct, adding in additional factors. Two big areas that we've gotten into recently is looking at training, deep learning, and that neuromorphic integration. I would say neural network experts will probably shoot me for saying this, but really neuromorphic integration is just me taking your brain and integrating into the system. How would you process it? How can we make that AI system smarter? And then I think another important aspect is the human in the loop. So yes, we have completely autonomous systems that don't need a human in the loop, but having that capability to have the human in the loop. Machine learning's also helped with all of our push toward autonomy to look at trust and autonomy. So these are just a couple of highlighted use case examples. Again, a lot with maintenance training. We're seeing it a lot integrated with augmented reality, looking at fault detection, looking at procedural compliance. Hey, this wasn't fixed. Did you go through all the steps that were required, or are the steps that are required wrong? Looking at cognitive enhancement and decision fatigue. So looking at both decision fatigue and how can we enhance that fatigue. Sometimes you're in an environment where you can't get out of it. You have to continue. So looking at how do we improve some of that. And then really the big one I see for AI and ML is that personalized and adaptive learning in any environment. So it could be in an extended reality environment, or it could be in a classroom environment. So just some training applications I wanted to highlight that involve a lot of mixed reality. So LVC obviously is blending live and virtual environments. You can do a lot of complex multi-echelon, multi-environment training. So you can have the guy who's on the ship and the guy who's on the ground, the guy who's on the air, and you can use VR and AR systems to integrate everyone together. Technical engagement simulation. So looking at mission assessments and mission completion that's very accurate. Looking at weapons effects. So we talked about haptics. So when I fire that gun, how do I get that feedback? How does it feel to me? How does it look to me? We're doing a lot now with integrated biometric systems. I say the environment today, a lot of companies are doing a lot with integrated biometrics. So not just having the wearables, but looking at real-time physiological assessment and what that means for the individual. Like, hey, this individual's heart rate is really high based on our general scale, but is it high based on their individual scale, or it's low? How do we stimulate? How do we make this individual's heart rate high? How do we stress them out for this training? We talked a little bit about distributed network training. So again, I'm here, I'm able to train with someone in California as if they're standing right next to me in this VR environment. And then another big buzzword is this digital twin and synthetic environment. The ability to train as if I'm physically in California, Afghanistan, or Iraq, I think is really important. One thing I didn't mention is a lot of these VR systems, not so much the AR systems, have been deployed. So we develop a training system. There are systems that have been over in Iraq and Afghanistan. There are systems that are on ships that you could do that real-time training as you're remote. What I do want to highlight too is some ethical considerations. So as we move into this AI ML world, looking at for training specific, how do we train positive transfer of knowledge? How do we make sure these individuals aren't getting that negative transfer carryover? Still having that, I really believe that human oversight is going to be needed for a significant amount of time. Looking at that bias always comes up too as we're tracking an individual, their privacy and their performance metrics. How do we do that in an acceptable way? Looking at different levels of autonomy, and then validation. It's really difficult in the VR and AR world to get quantitative data to say, hey, this made me a better, faster learner. that's truly quantitative. A lot of it's qualitative. Or, hey, it's you said I have to train to do this in 6 weeks, but in this training environment, I'm right there in 2 weeks. So really looking at a lot of that capability. And then for military integration, ruggedization, if this system's going out in the field, it will get dropped, it will get thrown, it will probably get driven over. So how do you make sure it's truly ruggedized? A standalone system, so having getting rid of that tether capability, looking at power management. Nobody wants to add extra batteries to their system, so can we hot swap batteries? Can we use the standard batteries that are out there? This is a big one, I think, integration across platforms with hardware and software. Everyone, great company model from a business perspective, right? Develop your own training that nobody else can use, and you have to customize. I think we're finally, especially from a DoD perspective, moving towards a broad access platform. So everyone has to develop on this platform to these standards to make it much easier. Security protocols, a lot of the training we've developed have been on-premise, not cloud-based, just much easier to deal with. But we are moving a lot to cloud-based, especially with these network integration systems. So looking at what those protocols are. I think we've done a lot with respect to improved terrain and environmental modeling, especially in the last 5 or so years. We have that capability to integrate several different scans together. Then the scenario development pipeline. So the ultimate goal is anyone can come in, I've been over to Iraq, I come back here, I want this exact scenario, I want this exact training plan. And all I have to do is type in, kind of like that AI model, right? Type in, this is the training scenario I want, and have that automatically developed. After action review system. So I think we've come quite a far way. We look at it from a machine learning perspective. So we know what you're supposed to do and building that swim lane on how to improve. One thing I will highlight in the after action review system, we're finally starting to see the importance of expertise integrated into training. I think a lot of times before we saw, oh, I'm a software developer and I'm going to come and I'm going to develop training for how to build a ship without ever having the guy who built the ship. So I think we're finally getting to the point where we understand you need to have that council of experts to help build that training. Only a few more slides. So challenges, always a simulator sickness issue. If you're in a moving environment, but you're not physically moving, how do we work with that? How do we look at physiological adaptation? Obsolescence management, tech refresh. So obviously these headsets are coming out faster and faster. We're looking at new sensors and new technology. How do we integrate across the board? Looking at scalability. So VR system is nice. You design it for one person, maybe 10 people, but how do you look at it for an entire platoon? How do you do that training across the board? Bandwidth, if you are transferring data, how do you optimize that data transfer? And then what I mentioned before is that training, transfer, validation, looking at how it really is effective and how you're getting that positive transfer. It's at an Army meeting recently, and we're talking about autonomy for autonomous ground vehicles. And they said, well, how do we know if we're in this environment? How do we know to get to the next step? And the Army guy said, well, I know, I've done it before. So really capturing how do they do that in that environment and putting it into the training environment. 2 slides now on the future of advanced technologies. So looking at blended training approaches, looking at step-by-step integration, not this is it, this is your next training, you must use it. I think really looking at you're still going to have that on the job, in the field training. You're still going to have some type of classroom, death by PowerPoint type training. Looking at qualifications, certifications, recertifications. So getting whether it be the government or industry to accept, maybe we can certify with VR, maybe you can't, maybe you could recertify with VR. Brain computer interfaces. So not just for measuring kind of EEG, measuring brain waves or ocular movement or muscle movement, but also looking at how can we integrate some of that. So maybe you have decision fatigue. Can we stimulate you somehow to remove that or reduce that decision fatigue? Quantum computing, I don't think we're quite there for the AR, VR, but I think we're getting close. So really just faster, better computing capabilities. And then looking at that goal-centric focus. So I guess I'll come back a little bit to the brain-computer interfaces. I see a lot of pulling from the medical world, maybe not necessarily from military medical world, but medical world in general, where we use brain computer interfaces to try to improve. You lose a hand, look at hand movement, or use a leg or a computer aided prosthetic. I see a lot of that transfer now. Hey, if we could do that and we could train an individual to think they're opening and closing their hand, can we do that in a virtual or augmented environment to kind of learn what they're thinking and make those changes? So just this is my final slide here, looking at how do we future of advanced technology with respect to training. I want to hit home. It's a rapidly changing landscape. If we're not using these cognitive enhancements, if we're not using this AR overlay or AI decision-making enhancement, somebody else is. So how do we make sure that we're getting there? I do stress the balance approach. I don't think that AR or VR or any type of this training is replacing that human in the loop and that human decision making. I still think we have that capability, especially on the battlefield, to do a better job, but have that augmented human computer interface. I think it's very important that we drive home that training effectiveness versus technology novelty. So not, hey, this is the next coolest device, but what's your problem? How do I make this device or this software solve your problem? I think we're continuously adapting. I think we're going to see 5 years from now a whole new scale. I know, VR headsets were very heavy and tethered and uncomfortable years ago. Now, you have kids who are at home, playing video games in them. You have the multi-directional treadmill. The kids are playing shooting games, things like that. I think we're going to continuously evolve and change. I also think it's a changing landscape with kind of the younger workforce and the younger military coming up who had computers in their cribs. They're used to this. They want this human augmentation. Cross-domain learning. So just from a sea, air, space type environment, looking at, especially from space with a big push for Space Force, can we do this training and test these different environments versus having to go in space and do this training? Can we do it real time here? And will it be the same as when we go out there so we're better prepared? And then just the complete system, kind of this holistically integrated system. When I talked about all the different features of VR and AR, do we need them all? Like if we're going to do ground-based training and we just want you to get from A to B, do you need haptic feedback? Do you need all the spatial sound? Versus if I'm doing like neurosurgery, what feedback do I need? How accurate do I need to be? So just some kind of considerations as we look at AR, VR, and then kind of data mining type training. And with that, do we have any questions? Absolutely, I agree. I'm not going to try to repeat all that, but I think no, I think that's kind of in summary, I think it is really important, especially with breakthrough technology or new technology that's foreign to us that, hopefully is also breakthrough. How much can you simulate in an environment to get someone to understand the process and the importance of it? I think I understand the system you were describing, probably, enough to be dangerous, but because I've seen it and I've talked with your team, but for someone who hasn't seen it or talked with the team, like to just understand how important it is, I think that VR holds a lot of weight in that simulated environment to say, this is critical, this needs to get out there. Yeah, absolutely. I agree. So for those online, we're talking about, telemedicine in the rural environments and desert type hospital environments and the importance of having that capability. I think telemedicine makes me another true believer, just the capability to do that operation here and have, the person so many miles away and it's successful, I think is very huge. Yes. Sure. I think it gives a lot of operational insight. You're right. And you can go through the 10 ways that goes wrong and this person dies without them dying. So I think there's a lot of simulation group gives us great potential to try it out before we try it out on and face the consequences type thing. All right. Thank you. Oh, yes. Yeah. Yeah, I haven't done the testing. A lot of the universities we work with have, and they've noticed an increased retention and memory. And a lot of it, I think what's difficult is, do we say it was VR or do we say it was you're more interactive, right? So I think security training, when I have to go through security training, am I really listening to everything they're saying in this training, or am I just getting to that multiple choice at the end and figuring out how to answer the questions? We all do it. So, but we find in like the VR environment, because you have to be interactive, there's a debate. Is it really the VR environment or it's because it's interactive? We've also found with the younger generations, because they're more used to interacting with a computer than a person, they have better retention in these environments, just based on, hey, here's a typical training we put them through, and here's the VR-based or AR-based training. They have better retention because they're more willing to talk to, interact, and ask questions of the computer versus a person. So sad but true, but we're seeing a lot of that. And then when we look at testing 6 months, 12 months down the road, there is a great retention because they were in that interactive environment. So it could be VR, it could be AR, it could also be that interactive stimulation. Excellent. All right, you get off. Thank you, guys.
So real quick, we're running a little bit behind, but I wanted to see, just by show of hands, do you think we should grab lunch now, or do you would like to see one more speaker before we break? One more speaker? All right, that's what we're gonna do. So give me 2 seconds. I'm gonna prep Byron and we'll be right back with you.